Good afternoon and welcome to a presentation for Team 6. We are Team Quilted Tutorials and our project for the FAIR Codeathon is to build tutorials for the Spark ecosystem and host them in an online hub. The NIH Spark initiative has developed an ecosystem of open source tools and carefully documented sets of data underpinned by the principles of FAIR, which are now primed for utilization by people within and outside the Spark community. However, we see an opportunity to lower the barrier for entry into the Spark ecosystem because many existing tutorials show in detail how a particular Spark tool can be used on its own, but do not document how these tools can be used together for building workflows. We have developed a hub for online tutorials with the goal of realizing the potential of the tools that are currently available within the Spark ecosystem. We have populated the hub with tutorials that demonstrate how Spark tools can be used for unified workflows. These initial tutorials lay the foundation for what we envision to be a series of tutorials hosted on our hub that serves as a place for new and current members of the Spark community to learn about ways in which Spark tools can be used collaboratively. We expect this to empower a broader user base to access and use Spark data and tools and grow the Spark community. Our platform will be a place for the Spark community to actively contribute tutorials and share with others within the community. Our online tutorial hub is accessible via a website and provides a list of all available tutorials. Our first tutorial shows users how to map 2D spatial neuron data onto a 3D rat stomach scaffold. We use Pensieve Web API for data acquisition and Spark scaffold mapping tool to produce a WebGL encoded mesh of the rat stomach, which was then converted to STL and visualized within a Jupyter notebook. The result of our tutorial is an interactive figure in Jupyter Notebook showing the projection of the three types of neurons on the surface of the rat stomach. In the second tutorial, we make use of the same workflow, but instead of projecting 2D data onto a 3D scaffold, we demonstrate how the 2D data can be processed for computational simulations. Statistical processes are used to compute a probability density estimation of neurons on the surface of the stomach. This density function can be used to simulate networks of neurons that are generated using data-driven probability functions. In summary, we have produced a generalized unified workflow for acquiring experimental data and processing it using only resources from Spark. Our approach is creative because it encapsulates a workflow within a Jupyter notebook, which is designed to be readily accessible to new users of Spark. Having a hub of tutorials that can be easily engaged will not only accelerate growth of the Spark community, but also increase uptake and usage of tools by members within the community. Thank you for your attention, and we hope you enjoy the tutorials we have created.